Okay. So, do you guys see the problem here if we try to use law of cosines on example A? Like, we could try to solve for side A or C first, and say like A squared equals 27 squared plus C squared minus 2 times 27 times C cosine of, I guess we could figure out angle A, right? We could subtract from 180. So 78 minus 20 is 50 degrees. But what's the problem with this? Why isn't this going to work?
There's not enough information.
Yeah, like I have another variable in here, C, which if I were to try to solve for C the same way, I would run into the same problem. And like doing a system of equations wouldn't really work. I guess it might. I've never tried, but we don't want to try. This is a situation where we need to use law of sines. So we're going to use law of sines today. Law of sines works for angle side angle or angle angle side and the infamous angle side side. You guys might remember from geometry, hopefully you do because no one ever forgets this, that angle side side doesn't work to prove triangles congruent. The reason why it doesn't work is you can have two triangles with the same information under certain circumstances. So you could have that triangle and you could also have this triangle right here. So basically that side right there, if it's short enough, could be in two places there. And so it's like an ambiguous case, like we can have two possibilities. And so that's why it doesn't work to prove triangles congruent, because congruent triangle proofs are all based upon the fact that if you have three sides of a triangle, there's only one possible triangle you can make. So every triangle with the sides 3, 4, and 5 is congruent to every other triangle besides 3, 4, and 5. Angle side side doesn't work that way. This is the part of law of sines that is hard. This is the part that we're going to do next class because we're basically going to be finding both triangles. We'll have to figure out how to do that. So that's next class. It's going to be a hard class. Okay, so today we'll do easy stuff. Angle side angle or angle angle side. We won't run into any difficulty here. Law of sines is going to be just fine. Here's the law of sines. It looks like this. So there's two different versions of it. One is with sine on top. The other is basically the whole thing flipped upside down. Depending on if we're solving for angles or sides, we'll use one or the other. It's the same law. One's just inverted. And also notice this is like a 3-part equation. We don't actually solve it in 3 parts. We just pick 2 parts and solve those. But all of those things are equal. So that's how you do it. Pick 2 and solve. We solve by cross multiplying, basically. Okay, so first of all, if we have 2 angles, we can just always find the other angle by subtracting from 180. So we should do that. We should find that missing angle is 50 degrees. And now we set it up. So since we're missing A and C, we want the version of law of sines with the sides on top. It's just easier to solve. So we'll say A over sine of 50 equals 27 over sine 28, and that equals C over sine 102. Today's class, we'll always use the version that has the sides on top because we'll be able to find all three angles right away. It's next class that we'll have to flip this equation upside down. So we just picked two of these. Don't pick these two to set equal to each other. Why not? What's that?
You don't want the side length.
Yeah, we don't have either of those side lengths. So we just want to pair up one of these with the one where we know everything. So we just have A over sine 50 equals 27 over sine 28. Turn to your neighbor. How do you get A by itself?
Multiply by sine 50.
Yeah. This is what we call a one-step equation. It's literally the easiest possible equation. Multiply both sides by sine 50. Boom, we solve for A. This is what we put in the calculator in Desmos, which you guys will have a chance to do in a sec, but I covet your attention, so don't do it yet. We would just do 27 divided by sine 28, and then that whole thing times sine 50. So don't multiply it on the bottom, put it out here, sine 50. Make sure we're in degree mode because I just got a negative answer, so like that doesn't make any sense. It's because I'm in radian mode. So it's 44.056. Then, when we're solving for side C, we're just going to grab these two. Even though we know what A is, we shouldn't use that number that we just found just in case we made a mistake. Like, use the given information always. So we're going to set up our equation here. 27 over sine 28 equals C over sine 102. What do we do to get C by itself? Yeah. Multiply by sine 102. Yep. So in my calculator, I just type it doesn't matter the order that I do it. I could do sine of 102. If I do sine 102 first, I should close the parentheses. Desmos will get confused if I put stuff after that number that's inside. Times 27 divided by sine 28. We get 56.255. Okay. Quick math question for you guys here. Is what we just did the same as that. Is that going to give me the same answer that I just got? Turn your neighbor, talk about it.
No.
Why or why not?
Yes, it would. It would get the same because it's all, because it's over one. So we just
Thumbs up, that's the same thing. Thumbs down, that's not the same thing. Thumbs sideways, I don't know. Oh. Yeah. Everyone tell me who your third grade math teacher is. They're going to be disappointed in you. 27 sine 102. Let's put that in parentheses there. Or no, divided by sine 28. Same thing. Same thing. Same thing. Okay. Why? Because math. So what we're doing here is 27 over 1 times sine 102 over 1 times 1 over sine 28. It doesn't matter the order. Doesn't matter if sine 28 is underneath one of them or underneath both. It's three numbers multiplied together. So order of operations, these are all the same thing right here. Okay. Now, be careful in Desmos. Like I said, if you do sine 102 times 27 divided by, let's just put that in parentheses there, divided by sine 28, it may or may not give me the same thing. It's not giving me the same thing. Turn to your neighbor, why is this the case? Because I just said that the order shouldn't matter.
Sine of whatever 102 times 27 is.
Yeah. Desmos thinks I want the sine of, where's my mouse? Where'd it go? There it is. Oh, I have any idea what 102 times 27 is. It thinks I want the sine of 2,754. I don't want that. I want this. Oh, look, that's the same. So just be careful. Close the parentheses if you're doing numbers afterwards. But remember, like, if you're ever in doubt, are these two things the same? And you have a calculator, am I allowed to do this? Just type in both and check and make sure you have the same number. So, yeah. Okay, so that's the easy part of law of sines. Would you agree that it's easy? Solving one-step equations. Yeah, it's great. If we have angle, side, angle instead of angle, angle, side, there is literally no difference. So we find our missing angle there. And again, since we're solving for sides, we want like a over sine 75 equals 34 over sine 45. And once you get the hang of this, you'll just pick two. Instead of writing out all three, just pick two that you want to work with. And then we'll do c over sine of 60 equals 34 over sine 45. And again, these are both one-step equations. This one has a fun twist of like we know the sine of the sine of 45, we know the sine of 60, but we're doing decimals anyway, so you don't need to use unit circle here. We just multiply that one on both sides by sine 75, multiply this one by sine 60. And that's it. So, one point I want to make here, when it says check answers for reasonableness, what we want to remember is the longest side is opposite the largest angle. And the shortest side is opposite the smallest angle. which means the middleist side is across from the mediumist angle. Also, there should never be negative sides or angles. Ever. Your biggest culprit, if some of those things are not true, let me just add another page in here so I can scroll down. Your biggest culprit is going to be, in order, probably check the mode, make sure you're in degree. So if your answers are just crazy, they're making no sense, just like, you probably just are in radian mode. If you like open a new tab and still go to Desmos, like on the new tab, it's going to reset to radian mode. If you like hit refresh, it might revert to radian mode if you're using Desmos. So just be careful. The TI is going to stay in whatever mode you put it in, unless you reset your memory, in which case it will go back. The second most common culprit is parentheses. Like you probably forgot to close a parentheses on sine, which again you only need to do if you're doing stuff after it. But those are your culprits if you're getting things that don't make any sense. So when we look here at example 1, notice C, which was 56, that's opposite 102. That's the largest side across from the biggest angle. 27 is the shortest side across from angle 28 there, which is the smallest angle. And then A is right in the middle at 44, and it's across from the 50 right there. So we can just kind of check and make sure that that makes sense. If I got some crazy number like C equals 1,000, you know, and I have a side that's 27, that's probably not right either. So now we're back in the world of like everything's tangible, physical shapes, like, you know, we know what's going on. So you can check and make sure your answers make sense. The very last thing that I see sometimes, please don't do this, thank you, is doing stuff like A over like 50 degrees equals, what do we have, like, or A over like 75 degrees equals 34 over 45 degrees. This is never going to work in a million years. What are we forgetting? It's obvious. Sine, yeah, we need to have sine in there. It does happen on tests, believe it or not. Don't do that. Okay, I mean, that's like, that's law of sines. That's what we're going to do today. It's a good lesson for a Friday, huh? Next class, it's going to get more complicated. But
Great for a Tuesday.
great for a Tuesday. Exactly. It's a perfect Tuesday lesson. Precisely. So, similar to last class, you guys have a Delta Math option or a paper option. The paper option is like finishing this. I know it's a lot of pages, but the examples are really spread out. That's why. And Delta Math will be available in about 2 seconds.